Hi, in this video we are going to discuss ArrayList, which represents the implementation of the list data structure using the array. First, let's shortly describe what is list itself. List is an abstract data type provided with the list interface in Java. It represents an ordered collection of elements that allows duplicate items. The user of this interface has an exact control over where in the list each element is inserted and can access the elements by their integer index. There are different implementations of the list, one of which is the ArrayList. ArrayList is a resizable array implementation of the list interface. It is backed by an array, meaning it uses an array for storing its elements. From the previous video in our series, we know that the arrays in Java cannot be resized unless we create the new one. So under the hood, once the certain quantity of elements are reached in the array list, it will copy all the elements into the new array, which will have an increased size. ArrayList implements all optional list operators. We can add all elements in the array list, including null. When we talk about ArrayList, it is important to distinguish two concepts: size and capacity. Capacity is the maximum number of items the list can hold before it is going to have to be resized. Size is the actual number of items in the list. For example, when you create an array list with the capacity of 20 and add only 2 elements to it, then its capacity will be 20, but the size will be 2. When we initialize the new array list, its default capacity will be 10, unless we pass another value for the capacity as a constructor argument. Now let's demonstrate creating and using ArrayList and some of its methods. So in our main method, we should type list of, let's say it is a list of employees, and call it employees, equals new array list, because this is the implementation we are going to use for this particular list, employee. Then we have opening and closing parentheses and semicolon. Now let's define this class, employee, which will be for this example purpose only, so we will just simply provide private string first name. Also, let's have another field which will be string last name, and let's also right click and generate constructor for these fields, taking 2 of these fields as an argument, and also let's generate getters and setters. And finally, we might also need toString method in order to see the contents of the object fields. So generate toString. And that's all we need for now from this class. So if we get back to demo class, and if we go here and push the buttons Alt plus Enter, it will import this class list. We need Java util package. And also same goes here to import array list. And this is our declaration and initialization of this list of employee objects. Now let's call some of its methods. So let's call add method, and we can pass new employee here, employee object. Martha, Wayne, let's push Ctrl plus D, duplicate, and let's edit the values, Thomas, Wayne, and let's also provide here James, Richards, and for this purpose that's enough. And you can also notice here at the editor that actually providing employee in here is verbose, so we can just eliminate it. So we can just replace it with this diamond sign, diamond shape signs. So after we have added several elements, we can system out print line employees, or you can just simply do employees dot SOUT and hit the tab. It actually does the same thing. And if you run this program, let's see the content of this list. if the elements actually got added. And we can see right here that this list has this content, including all these objects: Martha Wayne, Thomas Wayne, and James Richards. So that's about add operation. Now let's also demonstrate employees add, and let's demonstrate adding by index. So let's say we want to add some object at the index 0. So we indicate index as an integer, and now we indicate employee object which we want to add. So let it be Mary Jane, and let's see what happens. So run this program again, and let's review the content. So in this case, we can see that first element is Mary Jane, and it is not Martha Wayne anymore. Previously it was Martha Wayne, but since we added at index 0 Mary Jane, we can see that Mary Jane is the first element. Next one is Martha Wayne, and so on. So what happened is that at index 0 we just added new element, and all these remaining elements just shifted to the right position by 1. So if we check if this is correct, the position of this element index 1, now it should be Martha Wayne. And when we run this program again, we can see that on index 1, now we have Martha Wayne. Why? Because we inserted at index 0 Mary Jane. And that's why. We can also demonstrate several different methods. We can also check if our list contains certain object, or we can remove. We can remove either object or remove by index. For example, let's remove index 0. So actually it will remove the object which is at the index 0. And let's run this program again to demonstrate. And now we can see that Mary Jane, which was at index 0, got removed. And now the list content starts from Martha Wayne, then it goes to Thomas Wayne, and so on. That's about removing. And let's also type employees dot and review different operations. So we can also call for each and pass the consumer. Also we can do replace all, which takes unary operator. We can also use a stream. For example, if we call this dot stream method, it will turn our employees to stream, and we can apply functional programming style. For example, we can perform certain operations such as filter, and we can filter employees and let's say get last name equals, and let's say we are filtering for the employees with the last name Wayne. And finally, let's call terminal operation and system out println. And finally, it will print all filtered elements. Now we can get rid of these lines, and we can run this program again to demonstrate filtering. And we can see that we only got those filtered elements for this object of employees whose last name include Wayne. So this is about main operations of ArrayList, which I wanted to show you. Of course, there are many different useful methods of ArrayList class, which you can discover by visiting the documentation, playing around with it, and discovering some of its possibilities. Now let's discuss the time complexity. As we have mentioned, the ArrayList is using the array, which has a contiguously allocated elements in the memory, meaning that they are side by side, and calculating the position of any array element takes constant time, because each element has known dedicated memory space and it just takes simple calculation to reach any one of them. This is a great advantage for read operation, in particular getting an element by its index. Index is already known and there is no need to iterate and find the element. So getting an item by its index takes O of 1. Removing an element from the end will take O of 1 as well, because we know the position and there is no need to shift any elements. But if we remove an item from any other place, in general it takes O of 1, because after removing the element, all of its following elements should be shifted by one step left. For adding an element, on average it takes O of 1 when there is no need to resize, but in the worst case, when resizing is needed, all the existing array elements need to be copied into the new, bigger array, and then the element will be added. So this is n-time complexity because this operation depends on the number of the items to be copied. Now let's summarize everything we have discussed about ArrayList. ArrayList is an array-based implementation of the list structure. ArrayList is not thread safe, so if you need thread safety, you should not go for ArrayList. ArrayList is go-to class when you need list in general and you do not have any specific requirements or use cases, one of which is, for example, thread safety. ArrayList is quite fast when we are getting the element by index, because it is using array under the hood, and also ArrayList performs quite well in general for read-intensive operations. So this was all about the ArrayList for now. We are going to cover also other list implementations in our upcoming videos. If you like this video, please hit the like button and subscribe, and I'm going to see you in the next one.